Good afternoon, everyone. Thanks for introduction and thanks for coming to this session. My name is Yuntae Jeon, and I work from Smart Construction IT Lab from Seunghee University, South Korea. Today, our research title is GPT-based logic reasoning for hazard identification in construction site using CCTV data. Today, I will introduce how GPT can be applied into construction domain for detecting some hazard scenario at construction site. Here is our content of this presentation. Okay, in previous AI application in construction industry research, the most of studies focus on progress monitoring and safety management. Then what is the next 5 years research in AI application in construction domain? In recent, the multimodal AI, actually it is learns or understand the multiple source data like image with text or image with sound. In this case, this multimodal AI has the attention to its higher accuracy and also its similarity with human. So we think this multimodal AI with GPT is the next key of AI application in construction site. So the goal of our research is to automate the construction safety management using context-aware model with GPT for construction site scene understanding and the hazard identification. In the first scenario, there exists some deep learning-based object detection result like worker and signalman, PPE, and the construction vehicle and so on. In this case, just only the detection result the model or the result cannot know it is actually this scenario or not. It cannot only the detection result cannot influence it is risk or not. So, but also in the second scenario, this is the vehicle worker is walk into the vehicle, and this scenario, this case, only this the segmentation result or this case, the model cannot influence it is risk or not. So we use the GPT for understanding this context-aware scene. So the input is the CCTV image, and then the object detection and segmentation and depth estimation is used to multi-vision models from multi-vision model. Then we extract some useful information and with prompt engineering to GPT. Here is the one of the example of computer vision techniques. It is the depth estimation, monocular depth estimation. In our research, we only use CCTV images without additional 3D sensors. So we utilize monocular depth estimation, which can inference depth information from 2D image, and we compare the performance on monocular depth estimation with actual 3D LiDAR. And this slide shows some pseudo algorithm for prompt engineering, which is input for GPT. We explain in detail in follow slides. We utilize key point detection also for localize the position of worker, just in the case the object is occluded by other objects. As you can see in this, if the bottom part of worker is occluded, then our key point based detection result can possible to influence the bottom position of worker. And with this homography matrix between camera and bird eye view VEV map, we can localize the location of worker. Then if we set some dangerous zone, like as you can see in the red box, then the context-aware model can influence the worker is dangerous scene or not with other information. Like in this case, we use the detection and danger zone, but with homography, but GPT can understand with another information. So this slide shows from end to end our proposed pipeline. So the first input is the CCTV image, and we can also set some dangerous zone, as I mentioned before. It's the model run one by one is from maybe the computer vision based detection or segmentation something. So first we detect the worker and signalman vehicle, and we also learn the depth estimation model, which is the inference the 3D depth information from only 2D image. And based on depth estimation model, we can inference the distance in 3D distance from construction vehicle and worker. So we can give some alarm based on this also. Also, we can use the segmentation result also. So finally, the chip GPT gives some the result from educate. But I will show you the in detail next slide. So this is what we use. The left part is what we use the vision model, and the right part is the GPT model's output. So we also set some danger zone detection, depth estimation, and segmentation. The model, and we make some prompt. We make some the input for GPT, and the model, the GPT model, gets some prompt result, and then inference like in next slide I will zoom in the result. So as you can see in the right image, the object worker 1 is near to the ID 5. 5 is the construction vehicle. So it is lower than the safe distance. So it is dangerous scenario. Also, the second row also same thing. So like this, we can give some just 2D computer vision result like detection or depth estimate something. We just make many inference result and just put it to the GPT with prompt engineering. Then the GPT can inference it is the risk or not, identify it is risk or not based on some guideline. Like in Korea, they said KOSA guideline, and in US, they said OSHA guideline for construction safety management. Also, this is the same scenario, but different scenario, but same logic. Also, this is the different scenario with same logic. So in conclusion, we propose a novel end-to-end pipeline using GPT, which is the context-aware model at construction site with multiple information. In this study, we focus on few rules from KOSHA guideline, which is the rule of construction safety management, like the signalman should exist if the heavy machine is working, or some distance scenario, the safety distance. But in the future, we can directly give the entire rule from this guideline. Then our context-aware model can automatically identify some risk scenario. Maybe it needs some fine-tuning and something. Maybe it takes time for evolving the GPT, but it is our future work. Okay, thank you for attention.